So for this example, we are asked that a projectile is launched from A all the way to C, and it kind of shows this graph similar to this one, right? And then for part A, we're asked to find what's the work done from A to B, right? So we know to find the work done by the weight force is this. This is very simple. mg y1 minus y2, right? And something very important to note is that the y is actually the same for A and B. So we know that ya minus yb is going to be 0, right? So mg times 0 is going to be 0. So that's basically going to be the work done for that part. And then it's asking for the velocity of B, right? To find the velocity of B at B. So to do that, we know that the mechanical energy of A is equal to the mechanical energy of B. And what that means is the mechanical energy is going to be the potential energy, which is shown here, plus the kinetic energy, which is shown here. This is of A, right? And this here is of B, right? And we know that the y's are going to be the same. So if these are the same, that means that this whole part of the expression here is going to be 0, and so does this. So now we're just left with just the kinetic portion of it, right? So if the kinetic portion of it are equal to each other, right, that means that the velocities here have to be the same. So the velocity of A has to be equal to the velocity of B. Now for part B, it's asking us for the velocity from A, for the velocity of C, right? So to do that, we know that the mechanical energy of A is going to be equal to the mechanical energy of C, right? So we do the same thing as we do before. We put the change in kinetic energy with basically the potential energy, and then we equal that to the C of it, right? That was the A, this is the C, and we know that the YC is actually of the C is going to be 0 because it's at the floor. So this makes this whole part 0, and then we're left with this. The V of C, the velocity of C, to cancel out to solve this, we want to cancel out as many things out, so we multiply by 2 over m to cancel out, to isolate the v, and we do that, and then we end up with this equation here, right? Vc squared equals v0 squared plus 2gy 0, and that's the same equation there. And basically when you put any, you can put any velocity, the initial velocity, and when you square root it, right, at the end, you would get the velocity of C, right? And that's about it.